More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home, real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Hi everyone, welcome back to Mathnasium Schoolhouse. Just setting up here for our lesson. It's a Monday. Welcome to the start of the week. Today, as you can see, we're looking at equations, so hopefully that is what has brought you here. Some interest or maybe some review or some practice on solving equations. And I've specified there we're working with basic equations, and you'll see why that's the case. Of course, equations can get extremely complex, but we'll start with some basic ones for today. So go ahead and share with me who we have today. As always, I love to see your names, what grade level you are in. So go ahead. I have my comments open for the Facebook stream on my screen so I can always see what you guys are saying. I love the participation. Hopefully you guys know that by now, and if I haven't already said my name, I apologize. My name is Sandra, and I am, of course, the instructor for today. So go ahead and share that. Before we actually delve into the topic for today and really look at these equations and how to solve them, we'll, of course, do a slow introductory into them, and I have some puzzles for us to start with, some really fun ones. So while I wait for some names, there we go. I got my first one, Neva. Welcome, Neva. Go ahead and also tell me what grade you're maybe in. That's always interesting for me to know who we have in our audience. All right. I always like to mention if you have any sheet of paper with you or something to write with, that's always helpful just to keep track of the problems that we're working on. And because this is a lesson and I welcome any students in any level to join us today, you might just want to write down some exercises to review later. And as always, these videos are available on our Facebook page, so you could go back and pause where needed to really follow along at a pace that works best for you. So let's get started. As I said, oh, very nice, Arian and Vihan, thank you for joining us. We've got two on one account, very nice. As I said, today we're looking at equations, and although we'll be primarily solving equations, I don't want to just jump into some of the procedures that we'll very quickly get familiar with when it comes to solving these equations, and eventually all you want to do is follow these procedures. But I really want to also get an understanding amongst all of us of the components of an equation and how we can really, before jumping to a procedure, really attempt to solve an equation just from our basic understanding of what the equation is showing us. And so we'll look at it that way. It's a very beautiful Mathnasium approach to solving equations. And so before we get into that, you might be already familiar with equations, and maybe the representation, our favorite representation in math of an equation, is to look at it as a balance scale, right? So if you know anything about a balance scale, kind of think of a seesaw, but with the added component of a balance scale in that if you really want it to balance, so stay straight, you want to make sure that you have the same amount on either side. And if it's exactly what we're looking at, if it's a scale, then you want the same weight on each side. But the idea is you want the same amount on each side to balance it, to keep it straight. Okay? So we're going to practice our math muscles, of course, with some balancing act puzzles, as I said. So I'm going to go to my whiteboard, and let's start by warming up our minds with something that I have here. So we'll do 4 puzzles, one on each of these balance scales, but you can already start to see the scales here. So just a very rough way to show a balance scale is just the line there and the 2 legs on which that scale stands. Okay, so when you see this in these drawings here, these images, that represents our scale. And so above them, I'm just going to incorporate some numbers, and I'm going to ask you guys to comment what you think is needed on the other side to, again, balance out this scale. So let me give you an example. It's best to see a lot of these things through an example. I'm going to use my red here, and I am going to have the 3 squares on this left side of the scale represent 4. Okay, So what could you possibly tell me now that you know what this one side of the scale is equal to? What could you possibly tell me about the other side? So what can you tell me about this side, and maybe a little bit more than that, what can you tell me has to be in each of these circles to make sure my scale doesn't lop to one side, right? That this doesn't weigh more than this side or the other way around. I'll give you a few seconds to think of that. I promise once you get an understanding of this first scale, you'll be able to easily solve the rest of them. So I'll give you a few seconds to think of that. A 4, a 4, and a 4. Oh, I see an answer popping up. I like it. So I see, and if I remember your name correctly, that's Neva. Neva is saying a 3. I like that. I'm gonna add that in here. Let's maybe go through what Neva was thinking when they got a 3. So here on the left side, and I see it appearing now more and more, if you add up the amount of each square, 4 plus 4 is 8, plus another 4 is 12, that means my left side here is equal to 12, and so to balance it out, I need this to also be a 12. And so those of you that replied, Arian and Neva and Lavanya, thank you, you saw there were 4 circles. So how do I use that knowledge? If there's 4 circles, they need to add up. They're the same amounts because they're still the same shape. They need to add up to be a 12. So what needs to be represented by each of these circles? You guys maybe know your addition facts or your multiplication facts, which is even better. And you knew that 4 of the 3's, or 3 added 4 times, gives me that 12, which is exactly right. So I'm going to leave that there. Maybe I'll just write the 12 above here so you don't think that it relates to the bottom scale. But if that's helpful, I'll leave that there. I'm going to present you with the next puzzle. And I'm going to use my red to show you that on the left side I have 9 and a 9 in my 2 squares. So again, take a few seconds. Let me actually fill in the next few in case you get that really quickly. There are 5's in the bottom left one. Nope, yeah, that's right. And then I have a 10 and then 5's here. There we go. So I'll take a few seconds and then we'll jump into relating this into our bigger topic of today. But I'm sure many of you can already start to see that we're trying to balance out these scales, which is a very, very similar thought and approach that we take when trying to solve equations, balance out both sides of an equation. I see a 1 appearing. I'm not too sure what that relates to, but if you want to give me more detail, I'm more than happy to take a look. Let's go to this one here. See if you can help me out there. So 2 9's on one side. I can do that math for you. That gives me 18. Using that same approach, not even based on the first one, but just the fact that I know that to balance a scale, the left side has to be equal to the right side. So that has to be an 18 as well. So now I just start to think, okay, this one's just slightly different from the first puzzle because we don't just have all of the same shapes. We have 2 circles, so those have to be the same amount. And then we have 2 hexagons, so those have to be the same amount. Okay, circle is 3, okay. Let's put that. That's all right if you use the wrong value. And hexagon is 6. I like that. I'm going to include that. So you told me we have a 3 and a 3 and a 6 and a 6. Let's double check that that works. Okay, there we go. I see Lavanya correcting herself. Very nice. Oh, and I see another answer. Very nice. Okay, well, let's try this one out first. 3 plus 3 is a 6. 6 plus 6 is a 12. Let me add those on the side. Is 6 plus 12 18? It sure is. And then I'm also seeing, oh, 0's and 9's. That's a funny one. Okay, yeah, for sure. We can have 0's. Let's try to avoid 0's, but I do like it. I saw another one which I wanted to acknowledge. 2 5's and 2 4's. I like that. So that could definitely work, right? If I had 2 5's up here and then 2 4's, let's double check that that works. I would have a 10 from my 5 plus 5 and an 8 from my 4 plus 4. 10 plus 8 is in fact 18. There we go. Again, something beautiful that always happens in our math problems, right? More than one answer, which is wonderful. All right, let's jump to this third one here. I have 4 5s. 4 5s, I know that gives me 20, and I see some of you already helping me out with these problems. Thank you so much. So if I have 20 here, I need to make a 20 on this side. So let's see what you guys came up with. What am I seeing? A triangle is 8, okay. All right, what else though? I have also a hexagon and 2 circles. So I'm gonna put in an answer that I found, and you tell me if you found anything different. All right, so this is one that works for me. I just thought, you know what, let me get rid of a big amount using my hexagon. Oh, I see another one appearing. 10, right? Then I have a triangle, which is 2, and then 2 circles, and I decided they're both going to be a 4. 4 plus 4 is 8, plus a 2 is 10, plus another 10 is 20. That works. All right, and I see you guys are helping me out with more. All right. Okay, so let's try this one here. I have a 10, a 5, a 5, and a 5. Okay, so let's add that up. Let's do the 5s. Let's take care of the 5s first. 5 plus 5 plus 5 gives me 15. 15 plus the 10 gives me 25. Okay. Fifi, I'm not seeing anyone else tell me that they don't hear me, so maybe check if it's on your end on your computer. And if that's not the case, definitely let me know and I'll see if there's anything going on. So if I have a 25 on my left side, I need to make 25 on the right side. And I'm not sure if any of you helped me out. That's a great question. So someone is asking, Melanie, and I don't know if there's a student behind that, but you're asking, are the same shapes in different seesaws or different balance scales have the same weight? No, so I decided they don't have to, but that's a wonderful question. I could have decided that all the circles have to have the same amount, and that would just make it that much trickier. But that's a great question to ask, a great clarification to make. So I just decided they don't have to be the same. I'm treating each balance act differently. But thank you for clarifying. And let me just share what I had here. What did I have? I had a 10, I had a 3, and I had 2 6s. And you can double check that that works. Hello, Ivan. All right. Okay. All right, wonderful. I see a 3 appearing perfect. So you guys can probably see different ways to answer these. Now notice, and I'm going to just repeat this, I'm seeing another one, great, that balance scales represent an equivalence, and that's exactly what we were trying to do here, right? Both sides had to be equal to be in balance. So we're going to take this and translate it to equations, which is exactly why we're here. So I'm going to remove this, and if you want more of these, again, as always, feel free to reach out to your nearest Mathnasium, and I know they'd love to present you with more of these, all right? So let me remove this from here. And we'll draw a balance scale here, and I'm going to present you with another problem. So I'm going to have to draw them now. I'm going to give you a 20 here in my circle. And I want you to tell me, if I have 4 squares here, what has to be in each square? So go ahead and tell me that. So I have 4 squares, one side is equal to 20. I know that this side has to equal 20. What number, if I add it 4 times, the same number, gives me 20? And I'll write that in green. Hello, Madhav. Right. Hopefully you can start to see, if I add 5 4 times, I get 20. So I could have asked you the same question, right? I could have, instead of leaving the squares blank, I could have brought in some variables. And if you're not familiar with variables, you might want to, again, reach out to your nearest Mathnasium and see when you're ready to tackle them. But we will be working with variables today. So I could have here asked you, what is the value of x? Right? Or in other words, what does each square represent to then give me this scale in balance? Okay? So if you wanted to answer that, you could tell me, well, in this case, x is equal to 5. Okay? And we're going to be moving away from drawing out these balance scales. I apologize for that not being in view. There we go. Okay. And start to translate them into just equations. Okay. So what we can do here is, if I just remove this, remember that x was equal to 5, I can just translate into x plus x plus x plus x was equal to 20, right? This can just be thought of, remember that I said we can think of it as repeated addition or we can think of it as multiplication. We're going to be sticking with multiplication for today, so I can think of this as just x 4 times. Right? I'm adding x 4 times, you can see that visually, right? But x 4 times, if you've already seen this in the classroom, we can just write it out as, let's just use my blue here, as 4 times x is equal to 20. And then we can start to think, okay, now that I know that this is the equation that I'm working with, what number multiplied by 4 gives me 20, right? Or 4 times what number is equal to 20? And we've already found it. You guys are sharing it for me. That's exactly right. It is a 5, right? So we knew that 4 times 5 is equal to 20, and so x must be equal to 5. Okay. So let me practice that with you. I'm going to present you with a problem. I'm going to remove this. What if we have, and just do this mentally for now. We'll look at a procedure in just a second. What if I give you 6, and I'll give you, maybe we'll use the letter A. 6a is equal to 48. How could we find what a is equal to? And that's exactly what I want you to find for me. What is it equal to? Remember how we were thinking about this out loud. And if you need the scale, I can draw that for you in just a second. If I were to have this on a balanced scale, I would represent it this way. 6 boxes, where the boxes are just denoted by an A for now. So let's see if I can squeeze in 6 boxes here. And I would have A, 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 A. A, not 9. I know those could look like 9s. And then I would have a 48 here, let's say in a circle. That's the visual that I'm working with. We're going to stick with equations for today. I'm seeing someone write, a bunch of you guys are saying 8, and then Ivan says definitely 8. He's very, very certain that that's the answer. I love that. That's exactly right. It is 8, right? And again, just thinking out loud how you found this, you were probably asking yourself, all right, Sandra said I'm going to read this out loud as 6 times what number is 48? Going back to my multiplication facts, I know that, wait, 6 times 8 is equal to 48, and so that must mean that A is equal to 8. And if I wanted to just write that down, again, this is what you're thinking. 6 times some number is equal to 48. And that's what we found here. Wonderful. Thank you, everyone. Looks like we're all on the same page. That's beautiful. So let's move on, right? Right now, what we've been doing is just thinking back to our multiplication facts, thinking of solving these equations mentally, which is good. We always want to do that, and anytime we can do that, we're going to. Procedures sometimes complicate things, so if we know the facts right away, definitely resort to that. But sometimes that's not the case. So let's look at how we can solve some of these problems without performing the mental math. If in case the numbers, for example, get too big and we just don't know that multiplication fact. So for example, let's say I have the equation 13. I'm going to try to make my x's look more like variables and not a multiplication sign. But let's say I have this, and if you guys want to take the time to find the answer, go ahead. But the question here is still to solve for x. So let's figure out what this x is equal to. What is its value? Right? And as I said, in this case, you can probably already see, I'm not too familiar with my 13 times tables. I can definitely try to find it, but let's see if maybe there's an easier way to do it. And I'm thinking, maybe instead of resorting to multiplication facts, maybe I can resort to division. I'm comfortable with my long division, so I'm okay having to do that if needed. Okay? So of course, if we want to get rid of x, or in other words, we want to get x all by itself, we want to isolate for x, one way to do this is to get rid of the 13. And then the nicer way to say that in mathematics is to divide it out. Remember, we are dealing with opposite operations here. And remember, hopefully you've heard about this before, or maybe even just thought of it on your own. When we multiply, which is what we try to do here, 13 times what number is equal to 182? You guys are giving me the right answer, yay. We have to do the opposite to get rid of this, to kind of unglue them, right? And so the opposite of multiplication is division, and that's what we're going to be doing here. And I'll use my blue to show that for you. So since it's the opposite, I want to divide out to the 13, and just as a side note, remember that 13 divided by 13 is equal to 1. Any number divided by itself is equal to 1. And I think we saw that in some of Larry's lessons a few weeks ago. And so if I just take care of the 13 in here, so let me just write it on a new line. 13x divided by 13. What you do to one side, you're going to do to the other. So we'll do that in just a second. What does this give us? Let's figure that out here on the side. If 13 divided by 13 is equal to 1, 13x divided by 13, that x still remains there. That's just equal to 1x. Okay, this is just a side note here. Not to be confused with the work that we're doing. My sister said 14. Yes, 14 is absolutely correct, so give yourselves a thumb up for finding that out. For those of you that are confused how a lot of you guys are getting 14, this is what's happening over here. So what we do to one side, we do to the other, so that's what is happening here. And this is where I said we might have to resort to long division, okay? I'm not going to show it on the board. I don't want to complicate the whiteboard right here. But if I do my long division on the side, which I did prior to this lesson, 182 divided by 13 is in fact 14. And so that means I get 1x, and I'm gonna say that a different way in just a second, is equal to 14. So I keep saying 1x. Remember, all that means is 1 times x, right? 1 times something is equal to 14, and so that something is, of course, 14. And that's what's happening here. And I didn't do this magically one more time. It was long division. Oh, very nice. Jerry Ann said 14 because 13 times 14 equals 182. That's exactly right. Perfect. So let me present you with one more. Let me present you with 9 times some number, and we'll just represent that number with an x, is equal to 162. Yes, we are doing live classes every day. Thank you for asking. So go ahead and try to tell me what x is equal to while I look at Nick's comment here, which said 182 is 130 plus 52. 10 13s and 130. 13 doubled is 26. 26 doubled is 52. So there are 4 13s and 52. Wow, what a beautiful answer. Very nice. Great job. I love that reasoning. If anyone wants to take a look at what Nick wrote, definitely take a look. That is great. And that one just resorts to just facts and not having to go to long division. Thumbs up on that comment. Thank you for sharing. Okay, so what do we get here? X is equal to 18. As soon as I asked it, I saw it. Very nice. That's exactly right. So you're asking yourself, do I know my times tables? Yes, but maybe you only know them to 12, 9 times 12. That doesn't get you to 162, so you might have to do the long division. If you do that on your sheet, like Ivan's sister Viviana did, you get 18. That is exactly right. So here, after some work, you would get x is equal to 18. Why? Because 9 times 18 does in fact give us 162, right? Yes, thank you, Ivan. Tell your sister she is absolutely correct. Okay? And again, talking through the reasoning, we're multiplying currently on this left side. I don't know this mental fact, but I do know what I can do. I can resort to a procedure which is working with undoing what's happening on this side. 9 times x, or 9 times something, is 162. Let me get rid of that 9, unglue it from the x by looking at the opposite operation, which is division. And so if I divide out the 9 on the left side, I'm left with 1x. Okay, so I can kind of write that in if needed. 9x divided by 9 gives me the 1x. And then I take care of the division on this side as well. I know that this gives me 18. This gives me 1x. 1 times some number is 18. That means that number is 18. Okay? And once you get really, really comfortable, you can avoid this second last step. Once you kind of ingrain in your mind that 1x is always just equal to x. Okay? All right, let's move on. I'm going to give you back a balanced scale just to translate into a new form of an equation. So let's say I give you this, and I'm going to ask you to tell me what the square is equal to. So I have one square here on the left side, but I also have a triangle, okay? And then that is equal to a circle. I'm just going to fill it in with, let's say, 2. Let's say a 2 here. My triangle has a value of 2. And then I have, let's say, I'll make it a nice one, 22. So what is the value of my x? And again, I can just include let's say a capital M in there. So tell me what that M is equal to. All right. Let's take a few seconds to think, what is the value of this square? Notice that I've added a different level of, I'll say complexity here, but it shouldn't be too challenging. I see the answer showing up, yep. Notice that I've added a triangle to the left side, whereas before I just had a collection of squares. Now I have a square plus a triangle gives me the value of this circle. And I see the answer showing up, yes. So I kind of made it easier here just by choosing 22, just coming up with a question. But that's exactly right. M is equal to 20, which you guys are sharing for me. Thank you so much, right? So I'm thinking some number, and I'm just going to translate this to an equation. Some number plus 2 gives me 22. Okay? 22 is very nice. So what do I have to add to the 2 to get to that 22? Well, I know in my head that 22 is just 20 plus 2. And so I know fairly quickly that M is equal to 20. I don't have to do too much math there, just thinking, right? I could have made it harder and just had a bigger number here. But let's stick with this. Now let's say I'm going to keep this image and just add maybe, let's say I'm going to add one more square up here. Make sure you guys can see that. So that's still equal to M. So again, tell me what M is equal to. Thank you for sharing. Tell me what M is equal to if now I have, let's say, a 2 here still, but now I have a 24. So go ahead and tell me what this would be equal to. What is M equal to? Okay, so if I write this out as an equation, I have M plus M, right? There's 2 of the squares, plus the 2 is equal to 24. In our previous problems, we already saw that we can simplify how we write M plus M. It's just, that was just repeated multiplication. We can use repeated addition, and we can use multiplication to simplify that. And so I have 2M plus 2 is equal to 24. So what is M equal to? You guys are wonderful. Thank you so much. It is in fact equal to 11, right? Something plus 2 gives me 24, which means this something has to be 22. What 2 numbers added to each other or multiplied by 2 gives me 22? It is in fact 11. So let's squeeze that in here. M is equal to 11. Beautiful. Very nice. Thank you so much. So let's try now if I just give you an equation. So let me remove this. Let's practice a bit more. So let me take my black marker here. Let's say then I have 3 times x plus 5 is equal to 17. So I'm not going to show you the scales anymore. Let's try to work with just the equation. If you need to visualize it with a scale, absolutely go ahead on your scrap sheet of paper in front of you. Remember that we're working with equivalents, and so this left side has to be equal to my right side, which is just equal to 17. And remember that 3x simply means 3 times x, or 3 times some number, which we're just calling x for now. Right? Yes, I saw Ivan and Vivi said 11. Thank you for the previous problem. So try to complete this problem for me now. What do we think? I see the answers appearing, yes. Okay, so we have, again, let's approach it this way. Let's ask ourselves, I don't want to find x on its own just yet, but let me treat this as just something, right? This is a little bit easier to work with. Something plus 5 is equal to 12. So what should that something be equal to? Okay, well, I know that 12 plus 5 is equal to 17. So I know that this has to be equal to 12. So now I've simplified the problem for me. Now I just think, okay, 3 times what number is equal to 12? I know my multiplication facts, and so fairly quickly I can say x is equal to 4. Okay. So hopefully you followed along with that reasoning, but we can practice one more time with another problem. Okay. So let me give you just one more. Let's say I give you 5 times x plus 8 is equal to 43. Right? Tell me what x is equal to in this problem, please. Thank you for helping each other out with some of the audio issues. I love to see that you guys are answering each other's questions. Thank you so much. That's very nice of you all. What is the value of x? I'll wait until I see one answer appear. Okay. Jerry Ann, we have a few problems that we'll practice with, so feel free to jump off if you need to, and then these videos will always be available on Facebook to come back to. All right. So again, let me talk through what it is that I'm thinking here. I see a 30 appearing. I think I know where that's coming from. I personally don't want to think about x just yet. I'm going to simplify this for myself. Okay, great. Something plus 8 is equal to 48. Is equal to 43. Okay. That something then, I know because I can easily work with my addition here, that something has to be equal to 35. Now the question becomes a lot easier for me to answer. 5 times some number is equal to 35. I know my multiplication facts. Clearly you guys do too. Alexandra, Bina, thank you for sharing. It is equal to 7. Yes, x is then equal to 7 because 5 times some number, 5 times 7 equals 35. 35 plus 8 is in fact 43. Beautiful. All of this was done mentally, so how do we do this using a procedure? Well, let's see. Let's stick with, let's say I have 4x plus 7 is equal to 43. Let's just change it up slightly. Okay. Remember we talked about opposite operations with our previous procedure that we worked with. Same idea here. We just have to do maybe an additional step, right? So first we want to undo the addition. Similar to how we were tackling this mentally, I want to take care of the addition first. Okay, so to do that, I know that the opposite of addition is subtraction. So let me use my blue marker here. So I'm going to subtract 7 from this side because I don't want to deal with this addition part anymore. But what I do to one side, because we're dealing with this equivalence, because we're dealing with the balance scale, we got to do it to the other side. So if I subtract 7 from both sides, I am left with, let me actually use my green here, 4x plus 0, right? 7 minus 7 just gave me 0. Vivi, you're absolutely correct. And 43 minus 7 gives me 36. Okay? Adding 0, I know that that doesn't do anything for me, so I can really just simplify this to be 4 times x is equal to 36. So I'll do that in just a second. And once I have that, it's very similar to what we were doing before, right? So maybe I'll skip a few steps just because I don't have the space here. But once I'm left with 4 times x is equal to 36, remember what we were doing with the previous problems. We're multiplying, and so to undo this multiplication, we have to perform the opposite operation, which is division. 4x divided by 4 just gives me 1x, right? And so we would be left with, you guys can see that. I'll finish off in this corner in just a second. We would be left with 1x over here, and then I'd have to know what 36 divided by 4 is, but I know that fairly quickly. I don't have to resort to long division. I know that that's equal to 9 because I know my multiplication facts for 9, okay? So what I get here is, in fact, I should have used, let me use blue here just to show you that this is what we're doing, and this is what we actually get when we finish that. So when I'm finishing this off, I'll complete it here. I get, you don't have to write it this way, you can just write x if you're comfortable, but you do get 1x equals 9, and so 1 times something equals 9 tells me that that something has to equal 9. Now, what you'll always see in the classroom and what you should get very, very comfortable with is when you've solved some sort of equation, double check that your answer is correct, okay? How are you going to do that? You're simply going to plug back the number that you found as your x back into your equation and double check that the left side is in fact equal to the right side, because that is what we're doing here. We're looking at an equivalence. So if we found that x was equal to 9, let me remove this work and just double check, right? We always want to do that. So I'm just gonna, this is my equation. Let me use a green to see if it's true. So I am going to plug in my value of x, which was 9. If you've never seen this before, this just means multiplication. So there's several ways we can represent the operation of multiplication in mathematics. One is just the coefficient beside the variable. Another is when you're multiplying with two numbers, just use brackets. And you might have seen other methods too. But I'm just multiplying 4 times 9 here, plus 7. And I'm not going to right away say it's equal. I mean, the whole point of what I'm doing right now is to see if it's equal. So one way you can kind of do that is to put a question mark. You're still trying to see if it in fact equals 43. If you multiply 4 times 9, you get 36. We don't know yet that that equals the right side, but in a second we do. 36 plus 7 is in fact equal to 43. And so you can just kind of give yourself a check mark and say, yep, left side equals right side. The x value that I found is in fact correct. Let me give you one more to solve using a procedure. So I'm going to remove this. And I'm going to give you, n is our variable, so 7 times n plus 20 is equal to 6. Go ahead and take a few seconds to find that number out. You can try to do this mentally, or you can use a procedure. I'm going to recommend the second, just because here n gives you a funky number, and you'll see why in just a second. A really cool number, but maybe funky. So tell me what you get. I'll wait to see if I get someone answer, but take your time. I'm gonna tell you what I'm thinking in case that helps you out. I said before, 7 times some number, n, plus 20 equals 6. Another way to think of this is some number plus 20 is equal to 6. So what is that some number? Okay, that to me is a little bit difficult to find, and so what I want to do is perform some division. Okay. Oh, I see 9 appearing as the answer. We'll see. So let's say I want to follow the procedure because I don't know what that multiplication is going to look like here. I tried it mentally. It's not too great. I see the right answer. So I'm going to follow the procedure, which is to undo operations. We're going to start with the addition first. So if I subtract 20 from both sides, what do I get? So I haven't touched the 7 times n yet. Here, of course, I get 0 because I've subtracted it. And what do I get here? Okay, 6, if I subtract 20, and this is where I said it was a little, it's going to get a little bit funky because we're going to start to get into some negative numbers. If I take 6 and I subtract 20, those of you that have seen negative numbers, you move into them. Here you're going to get a negative 14. Okay? In other words, you have 7 times some number is equal to negative 14. We know how to deal with this. We want to undo the multiplication on this side using division. And so we end up getting, exactly as I'm seeing, n. So I'll finish this off here. Or 1n. For those of you that need to see that, which is great, is equal to negative 2. 14 divided by 7 is 2, or negative 14 divided by 7 is negative 2, which means that that's what we get here. And I see some of you are showing it already. Perfect. Thank you so much. Okay. Now, we've gone into some funky numbers now with our solution being a negative number. You will encounter negative numbers throughout any equations. You can have any combination. Fractions, decimals, really, really big numbers, negative numbers, and so on. So we'll practice that and look at what are some different approaches that we can take to some of these. So let's see. What if I had fractions? Let's say I had a bunch of fractions. Okay? So I have 3/4, I apologize if you can't see that, 3/4 times some x minus 5/8 is equal to 9/16. Let's look at just how to find this, right? So it looks very similar to an equation that we worked with before, right? But there are the fractions involved. So a couple things you can do is still approach it by isolating for x, very similar to what we were doing before. Undo the subtraction here, then undo the multiplication once you've done that. But another nice thing about working with fractions is you can look at the lowest common denominator and just kind of use that trick to get rid of the fractions as much as possible. And then you're left with a more nicer looking equation, I should say. So we won't necessarily finish solving it, but we'll look at this approach. So let's think, what is the lowest common denominator between 4, 8, and 16? What do we get here? If you've worked with lowest common denominators already, fairly quickly you can see that that is going to be 16, right? And so I can multiply all of these by 16 and get, let's see, actually let me just write this in here. So I can multiply this side by 16, this side by 16, and this side by 16. And so what actually happens here when I simplify it is 16 multiplied by 3/4 x, 16, let me write that bigger, times 5/8, and 16 times 9/16, or 9/16, I should say. Right? And so when I simplify this, I'll write this in black now, this will be our new equation, okay? I actually get, if you're comfortable with multiplying with fractions, different ways you can approach this, if that helps you out. Here I'm going to get 12x, or 12 times x, minus, and you can do the multiplication with the fractions on the side if you want to follow along later. Here I get minus 10 is equal to 9. And then this is the new equation that you're working with, and hopefully you can see and agree with me, this is a lot nicer to work with than what we had before. Don't get me wrong, fractions are beautiful in their own way, but we try to avoid them when possible, if it's possible to simplify what we're working with and get rid of those fractions. Right? So that's one cool trick that you can work with if you encounter fractions in your equations, which you are bound to. See how you can, I'm going to challenge yourself to see how you can possibly use the same technique to get rid of decimals when you encounter them in an equation. So I will leave you with an equation such as this, and think about what you know about place value and how you could possibly use it to get rid of the decimals here, right? Because right away you should be looking at this and thinking, okay, decimals, I can try to do them in my head. Oftentimes I resort to a calculator, which we want to avoid as much as possible. So what could I do here to just simplify this into a nicer equation, right? How, and this is what I'm challenging you to do, is how do you get rid of decimals? What do you multiply them by to get rid of it? Okay, so think, how many place values do I have here in my decimal numbers? Okay, perfect. So let me just visit maybe one more type. Another type of equation that you might encounter is something that looks like this. Let me show you an example. I just want you to see that they're not as scary as they might seem to be, right? A lot of the techniques that we've seen how we can use them in different types of equations so far. Another type that you might encounter looks like this. We've talked about what it means to use brackets in an equation. We know that that means multiplication. And so let's use the same reasoning in trying to solve for n in this case, right? So let's read this out. How would you read out this equation to yourself? This is what I'm thinking. 5 times n plus 2, okay, let me just simplify that in my head and just say 5 times something, so 5 times something equals 30. Can I find that very easily before trying to find n? Absolutely. I know that 5 times 6 is equal to 30. Let's see if my red shows up on the board. There we go, right? I know that 5 times 6 is equal to 30. So rather than dealing with what might look like an ugly equation or a scary equation, I've really now simplified it for myself to then solve for n. I know that then this something, which is the n plus 2, has to equal 6. That's what I just found. And this is so much nicer to work with, right? We've done a few of these already today. What number plus 2 is equal to 6? I know that really quickly. That is a 4. Okay? And if we didn't have such nice numbers, let's just use the techniques we had before, following the procedure, right? Sometimes we encounter some not so nice looking numbers that we have to use long division to find it out. So let's just look at one of those before we end for the day. Let's say we had 4 times something where that something was x plus 7. All of that gives me 72. All right, how do I solve for x here? I can try to do this mentally. 4 times something is equal to 72. I don't know that too quickly, and so what procedure asks us to do is to just distribute. This is called the distributive property, if any of you have heard of this already. We distribute this 4 that we would have multiplied by to each of the terms within the brackets. And so we actually get really a nicer equation once we do that. If I multiply the 4 with the x, we already know that that looks like this. Okay, great, you guys got it already. Thank you, Freddie. If I multiply the 4 with the 7, and there's an addition between them, I get 28. I haven't touched the 72, and now it's almost like a magic trick. Ta-da! We're back to a very friendly looking equation that we can solve. We went from something that looked kind of scary, right? How do I even approach that? But once I distribute it, it's very friendly. It's very, very similar to the problems we did in the beginning of today's lesson, right? And I know how to approach this. I can try to tackle it mentally. If I choose not to, that's fine. I take out my sheet of paper, I take out my whiteboard, and I start to undo operations, right? I undo my addition first by subtracting on both sides. So if I do that, I get 4x, or I should say 4 times x, plus 0 is equal to 72 minus 28, which is 44. And although I don't have space here, I'll just kind of talk the rest of the solution out loud, talk through it. 4 times x, and I don't have to include the plus 0 there anymore, is equal to 44. I actually don't even have to use long division for that because I know that that is equal to 11, and obviously so do the rest of you because you're sharing your answers, so that's exactly right. X is equal to 11. And if you're not comfortable with that, what we just did, go ahead and divide out by 4 on both sides if needed. Okay? Do what makes you feel most comfortable. There are a lot of different ways to tackle these. If you can try to do them mentally as much as possible, I promise that'll help you gain a deeper understanding of what equations are. And rather than looking at them as something that only high school students should see and that they're these scary things that now bring in letters into mathematics, I promise they'll become your friends. And don't forget, you always want to check your answer. So similar to what we did before, you want to go back and you want to see, I found 11, I followed the procedures that Sandra showed me, that Mathnasium has taught me, but I have to just make sure that I didn't make a mistake all along the way. And so let's go back and see if my left side does in fact equal my right side. All right, I'm going to end it off there. There are just so many different things that you can do with equations. Go ahead and take a look at the packet that will be shared with you in the comments in just a few minutes. Go ahead and practice some more. Don't be afraid to tackle some equations with fractions and decimals and negative numbers, as I said. I promise you can find a way to make them a lot more friendly than they might at first appear. Have a wonderful day, everybody. Smile loads. Go out and enjoy some sunshine if it's there with you today. Practice some math, and we will see you the rest of the week. Bye.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.